before we continue doing things we started last time, let me show you that there is a second homework assignment ready for you. At the end of today, you're going to be able to do almost all, or perhaps all of the exercises I'm assigning you. I'm officially going to announce this on Wednesday, and then I'm going to collect it the Wednesday after that. But do start having a look at these problems. And then on Wednesday, we are also going to have a tutorial. So prepare a question, send me emails, and attend the tutorial, and we'll go over some of these questions. Okay, so let me remind you what happened last time. Last time we introduced options, and then we said options, or at least this kind of options, come in 4 flavors. We can have either put or call options. So call options give the right to buy something at a certain price on a certain date, and European put options give you the right to buy the underlying asset, to sell the underlying asset at a pre-agreed price, which we're calling the strike price, on a special date. So there is a date on which you have the right either to buy if you have a call option or sell if you have a put option. And that date is the expiration date of the option, and the price that you pre-agree on, the price which the call option gives you the right to buy for and the put option gives you the right to sell for, is what we're calling the strike price. So these are the 2 first kinds of options we've seen, European call and European put options. And then we had the American counterparts to this. So now we had also American call and put options, and the only difference between American and European style options is that the European style option gives you the right to do something on a certain date in the future. American options give you the right to do something, either to buy or sell something, between now and expiration time in the future. So that's the difference between American and European options. And then I showed you some examples. And then I ask ourselves, what good do these options do for us? We ask ourselves, what are the payoffs of these options? So in this picture, we're looking at European call options on an underlying asset whose price at expiration time t is what we're calling S of t. And then we ask ourselves, when we get to this time in the future and we observe the underlying asset price at that time in the future at expiration, what happens to us as we observe different prices? We're talking about the price in the future. We don't know now what the price is going to be. We can only try to imagine what it's going to be. So if we imagine the price, suppose that we have a European call option with strike price x, so let's put the value of x on the underlying asset price at expiration axis. If we imagine ourselves landing on a world in which the underlying asset is traded for more than x, then we make a profit because we have the right to buy it for x, and then we can sell it for more than x. On the other hand, if we observe at expiration a price which is below x, then yes, we have the right to buy it for x, but everyone else is buying and selling this stuff for less than x, so we're not going to exercise our option to buy it for x. And then nothing happens to us, and we don't get any profits, any payoffs. And similarly, if I draw a similar payoff function, a graph of a payoff function for a European put option, so now we have the right to sell for x. Now, if everyone else is buying and selling at expiration for less than x, we have the right to sell for x, so we can buy this stuff for less than x and sell it for x. And we're going to make a profit. We're going to get a positive payoff. If the market price at expiration of this underlying asset is more than x, well, we're not going to be able to make a profit because everyone is buying and selling for more than x, us exercising our right to sell it for the smaller price. The lower price is not going to make us a profit. Okay, so this is what we've seen last time. We saw an example of putting options together in a bag of assets, which we call a portfolio, and then asking ourselves, what is the payoff of a portfolio of assets, of a portfolio of options? Now I've just seen this, and I remember I have to do something. So, okay, I'll hold it on my hand so I don't forget about this. So we've seen the example of a strangle, which has two options. One is a put option, the other one is a call option. We put them together, we ask ourselves what's going to be the payoff of this portfolio, and then we saw that it looks like something which gives you a zero payoff when in the middle, and you get positive payoffs if extreme things happen. And then we had this question over here, which I solved for you, I think. And there was one remaining thing we didn't do, which is the second part here. So, read the second part of this question, remember what happened here, and while you do that, I'm going to make some noise. I'm going to tell you what I'm holding on my hand. This is an attendance sheet that for some strange reason you have to sign. So I'm going to pass this around, and you sign next to your name. There are 3 pages here. The first one is for MAS362, a smaller one for MAS462, and another one for MAS6053, which are 3 different versions of the same course. So pass this around. Okay, now let's go back to this example and let's try to figure out what happened here. So someone came to us and they said, I want a portfolio of, in this case, European-style put options on some underlying asset, which in this case is stock, some shares in some companies, with different, the options going inside this portfolio are going to have different strike prices. But what I want from this portfolio, what I want it to do for me, is that at time t, at expiration, I get a payoff which is a function of the underlying asset price at expiration, and that function is that. Okay? So you are now a financial engineer. Your job is to come up with such a portfolio, and then you look at this and you say, so I'm going to do it very quickly because we've done this last time, but we're going to say we're going to have one put with strike, what was it, 30, and then minus 2 puts with strike 20, and 1 put with strike 10. And let me remind you what I mean by minus 2 puts. You can think of this in 2 different ways. You can issue a put option, in which case you're on the other side of the put option. So if the owner of the put option makes a profit of £1, it is you who is incurring the loss of that £1. Or you can think of just short selling it, in which case you take these 2 put options from someone, and then at expiration you have to compensate that someone for whatever payoffs they're expecting. So we said, this is what we've done last time. We said, here's your portfolio. It consists of these components. If you have this portfolio and you reach expiration time, the payoff of this portfolio as a function of the underlying asset price is going to be that function that is graphed there. Do we all remember this? I'm here, I'm trying to talk to you, talk to me please. Do you remember this? It wasn't that long ago, right? Okay, so now let's have a look at the second part of this question. It says, let P10 be the price of this kind of options, and P20 be the price of one of these options, and let's take P30 to be P30 is the price of options like this, P20 is the price of options like this, and P10 is the price of options like that. Okay, and then you have to show that that inequality over there holds. Why is that true? When you look at this function, what sort of function is that? What can you say about the values of this function? They look non-negative to me, right? Can you hear me? That function is not negative, right? Okay. What does it mean for the function to be not negative? I have this portfolio, I arrive to expiration time, and then what's going to happen to me? I'm going to get a non-negative payoff. This, at time t, which is expiration time, gives a non-negative, that's right, greater or equal to 0 payoff. So at expiration, what do I know about the price of this portfolio? Here's something which, at worst, in the worst case scenario, is not going to give me anything. In a better scenario, it's going to give me some positive number of pounds. What can I say about the price of such a thing? It's positive. So, price of the portfolio at that time is greater or equal to 0. So now I have this portfolio. In this hand, in my right hand, in my left hand, I have nothing. Absolutely nothing. How much do you pay for nothing? What's the price of nothing? 1 unit of nothing? Nothing, right? Okay, at time t, I have these two assets. My portfolio, nothing. The price of this is greater or equal to the price of nothing at expiration, at time t. What can I say about any previous time, any prior time? What can I say about now, at time 0? I have two assets. I know that at some point in the future, the price of this asset is greater or equal to the price of this asset. What do I know about any time before that? We have the same relation. So now I have this, which costs at least as much as nothing at expiration, at time t in the future. What do I know about the prices now? Well, the price now of this is at least as much as the price of nothing, which is still 0. So, the price now, if you want the spot price, of the portfolio is greater or equal to 0, right? Show me signs of life. Otherwise, I'm going to repeat myself again and again, thinking you don't know what I'm talking about. So let me remind you, you don't have to say anything. You just do this or you do that, and then... Okay. Fine. So I know that the price now of this portfolio is greater or equal to 0. How much do you pay for this portfolio now? How much do you pay for your one put option with strike price 30? What do we call that? This, right? This is what this is saying. Okay, so to buy this portfolio, I have to spend P30, and then I have to buy minus 2 put options, which amounts to me issuing 2 put options. So when I issue 2 put options, I'm paid twice P20. So it costs me minus twice P20. And also I have to buy the last component, which is one put option with strike price 10, which costs how much? P10. And what do I know about this? This is another way of writing the price of the portfolio now. This is greater or equal to 0. Right? You rearrange that and you get this inequality. Is this making sense? Okay. So now let's have a look at some new stuff. So now I'm going to show you some inequalities satisfied, some inequalities and equalities satisfied by the prices of options, European options. So we're going to look at different option types. We're going to start with European options. We're going to assume that all the options we look at have the same underlying asset, which I'm taking here to be stock, shares in some company. And we're going to give a name to the underlying asset price now, at time 0. We call it S for spot. And we're going to assume that all the options we're talking about expire at the same time in T years. And we're going to use X for the strike prices of options. And now I want to give names to the prices of options. So we're going to have little c and little p. These are going to be the current prices, the spot prices. The prices time 0 of European call and put options respectively. So call and put options respectively. And we're going to use capital C and capital P for the spot prices of American call and put options respectively. So what can we say about these 4 numbers, these 4 prices? So let's start with some easy things. First, the prices of any of these options is greater or equal to 0. They're non-negative. And the second thing I want to show you is European call options are not more valuable than the corresponding American call options, and those are not more valuable than the spot price of the underlying asset. And European put options are not more valuable than the corresponding American put options, and those are not worth more than the strike price. So let's see, this is an exercise in remembering what these options are. So let's see if we can do this. So suppose that, let's do one first. So suppose that one of these options has a negative value, minus v. Now, suppose that you want to buy one of these. Suppose if you buy something which costs £1, what do? You give £1 and you get that thing. If you want to buy something which costs minus £1, what happens? You receive £1 and the thing. So for example, if you were trying to buy toxic waste, then someone would give you a lot of money to get rid of it. So the price of toxic waste is probably negative. You get the toxic waste together with the payment. But let's assume that these options are like toxic waste. They have a negative value. We call that negative value minus v. So we buy it for minus v. So we receive one of these options for we receive one of these options, and on top of that we get v pounds in cash. What do we do now? We put this v pounds in cash in our pocket, thinking about lunch. And what do we do with the option? What is the option? The option is a piece of paper, a contract that gives you the right to do something. Yeah? So I can take this piece of paper and throw it away into the bin, and no one is going to come to me and demand anything from me. I just threw away something that gives me a right, so I'm allowed to throw it away. I'm just foregoing a right. So I can forget about the option, and I'm left with v pounds in my pocket. I just made a profit without any investment, and that's what we call a free lunch, and we don't have those. Okay, let's have a look at the second set of inequalities in part C. So let's start with this inequality first. Let's convince you that little c is less or equal to big C. So how do we do these things? How do we show that we have some relationship between prices? We say if this is not holding, then we can get a free lunch. So let's assume that this inequality over here is not happening. So in other words, little c is bigger than big C, and let's see if we can buy lunch. So what are we going to do? So we have something here that looks too expensive. We sell it. We're going to sell a European call option. We just gave someone the right to buy the underlying asset at expiration for X, for the strike price. And we're going to buy the corresponding American call option, which gives us the right to buy the same thing for the same strike price X anytime between now and expiration. Okay, so the first thing we can do is we can take the difference, we put it in our pocket, and we can then wait for expiration. And then what can happen in expiration? One of two things happen. We sold someone a European option. That person can come to us and say, I demand to buy this stuff for X. So I say, sure, give me X pounds. So you take the X pounds and you exercise your American call option, which gives you the right to buy this stuff for X pounds. So you take the X pounds and you buy the underlying asset for X pounds. Now you have the underlying asset, you give it to the person who bought the European option from you, and you don't owe that person anything else. So if the owner of the European call option you sold exercise it, you exercise your American call option, and then you can supply him with the underlying asset for X. You don't have to spend any money to do that. And if that option is not exercised, then you do nothing. In either case, you end up pocketing this positive amount of money, which you can go then and buy lunch with. And a very similar argument shows that the price of the European put option is less or equal to the price of the American put option. Again, if that's not the case, you sell the European put, you buy the American put, you wait for expiration, and so on. Okay, is this okay? Is this okay? Okay, now there are two other inequalities I have to convince you. There is this inequality over here, and there is this inequality over here. So let's start with this inequality over here. So suppose that the first inequality doesn't hold, which is another way of saying the price of the American call option is greater than the underlying asset price. So what are we going to do? Again, we sell things which are expensive and buy things which are cheap. So we sell the American call option, which you can do in the form of issuing one. You take the proceeds of the sale and you buy the underlying asset. And then you can pocket the difference. And then you wait. So what can happen if you wait until expiration, between now and expiration? Any time between now and expiration, the person to whom you sold the American call option can come to you and say, I have the right to buy this stuff for X, this underlying asset for X. You say, fine. I have this stuff. Here it is. Take it, pay me X. And then if the option is exercised, then you end up with this amount of money that you pocket initially together with X pounds. Otherwise, if the option is not exercised, you end up with this difference in your pocket and the underlying asset, which you can then sell it. In either case, you're making a certain profit without any investment, which is impossible by our assumptions. Okay, how about the other inequality? So I want to show you that the price of an American put option is at most the strike price. If that's not the case, if we have that other inequality, if P is greater than X, again, we sell the thing which is expensive, we sell the American put option for P, and then we wait. Now suppose that the person to whom you sold the American put option comes to you and wants to exercise it. What does he want to do? He wants to sell you something for X. So you buy this underlying asset for X, and where do you get your X from? Well, you started by selling the American put for more than X. So now after you buy the stock for X, you're left with P minus X, which by our assumption is positive. So you put this positive amount of money and you end up with a certain profit. We end up with this difference plus the stock we just bought. And if the option is not exercised, well, you just sold this American put option for P. No one demanded anything from you. No one demanded to sell you anything. So you just put the whole of P into your pocket. And again, you've just made a certain profit without any investment, which again, it's something which we assume cannot happen. So this inequality cannot hold either. It gives us a contradiction. Do you have any questions about this? Okay, so now let's see some other inequalities satisfied by prices. So here are two inequalities which are slightly more intricate. And we're going to have to do something slightly more complicated to prove them. So let's give a name now to the T-year spot interest rate. So let the T-year spot interest rate be R. And now I want to show you this inequality. So the price of a European call option is greater than the spot price of the underlying asset minus the strike price times e to the minus interest rate times time to expiration. And we have also an inequality involving the price of a European put option, and that's going to be greater than the strike price times e to the minus T-year interest rate times time t minus the spot price. So let's see how we prove these two inequalities. And to prove these two inequalities, we're going to look at two portfolios. We're going to construct two portfolios. We're going to check their value at some point in the future. We're going to discover that the value in some point in the future satisfies an inequality. We're going to pull this back to the present. We're going to deduce that we have the same relationship between the prices of these two portfolios at the present, and that's going to give us much of what we need. So what are these two portfolios that I'm going to use to show the first inequality? So in the first portfolio, portfolio A is going to have a European call option plus an amount of cash equal to X times e to the minus RT, which is going to be deposited for T years at an interest rate of R. So that's one portfolio. It has a call option and cash. And portfolio B is going to have 1 unit of the underlying asset, 1 share, 1 unit of stock. Okay, so now let's have a look at the values, the prices of portfolio A and B at expiration time t. So let's have a look at what happens after t years. So we look in portfolio A, and what do we see? We started with this amount of cash. After t years, when we are earning an interest rate of R, this is going to grow to this amount times e to the RT. And when we multiply these two, we're going to get X. So in portfolio A, we now see X pounds, and we still have the European call option, which we may exercise. And now we ask ourselves, are we going to exercise the call option in portfolio A? So what are we going to do? We're going to say, well, remember the payoff function. So we have a call option, a European call option with strike price X. And now we arrive to expiration. We have to decide whether to exercise it or not. We're going to say, if the underlying asset price at expiration is above X, we're going to exercise it, otherwise we're not. So we say, let me repeat myself, if the stock price S at time t is above X, we're going to exercise the option. What does it mean to exercise the option? We're going to be able to buy the option for X. So remember, in portfolio A, at expiration, I have X pounds. I can use this X pounds to buy the underlying asset, and then I'm going to sell the underlying asset for this price ST, which is above X. And in that case, if we end up in this state of the world, in such a state of the world in which we're going to exercise the option, we end up owning the underlying asset, which is worth ST. Now, what else can happen at expiration? So here, this is the happy zone of the future. What happens if we find ourselves here? So now we're not going to exercise our option. So after t years, we observe this, the price is less or equal to x, we're not going to exercise the option, and the portfolio is then going to be worth x. So there were two cases here. If we find ourselves here, the price of the portfolio A ended up being ST. If we found ourselves in this kind of states of the world, the portfolio A ended up being worth X. So how much is portfolio A worth? We can summarize it by saying it's going to be the maximum between ST and X. Because when ST is bigger than X, the portfolio is worth this. When ST is less than X, the portfolio is equal to that. So the value of the portfolio at time t, the value of portfolio A time t is the maximum between ST and X. And that maximum is greater or equal to ST. But now let's remember what we had in portfolio B. Portfolio B had 1 unit of the underlying asset. How much is 1 unit of the underlying asset worth at time t? It starts with an S. I'm holding in my hand the underlying asset of these options. And I get to expiration time t. The price of the underlying asset at time t is what we call and I gave you a hint, it starts with an S. ST, right? ST is what the underlying asset is worth at time t. Okay, so portfolio B is worth ST at time t, and portfolio A is worth at least ST at time t. So what do we know about the values of portfolio A and portfolio B at time t? Here's portfolio A, here's portfolio B. At expiration time t, the value of this is greater or equal to the value of that. So what do I know about the values of this and that now at time 0? They satisfy the same relation. So the value now of portfolio A, let's remember what is portfolio A. Let's write down the value now of portfolio A. What do we see in portfolio A? There's 1 European call option. What do we call the price of this European call option? We call it C. What else do we see in portfolio A? We see cash. How much cash? X times e to the minus RT. What's the value of X times e to the minus RT pounds? It's X times e to the minus X times e to the minus RT. And this must be greater or equal to the price of 1 unit of the underlying asset at time 0, which we call S. So we get this inequality over here, right? There's no point in me reciting all this if you don't know what I'm talking about. And I don't know if you know what I'm talking about if you don't tell me. So, do you understand where this is coming from? We said portfolio A at expiration is worth at least as much as portfolio B at expiration. Portfolio A has 1 call option and this amount of cash deposited for T years, which gives you X pounds at expiration at time 0. What do you see in portfolio A? 1 call option, which is worth this much, and this amount of cash. That's the value of portfolio A at time 0. That value must be must be greater or equal to the value of portfolio B at time 0. What does portfolio B have? It has 1 share. What name do we give to the price of 1 share of 1 underlying asset? We called it S. So the price of portfolio A at time 0 must be greater or equal to the price of portfolio B at time 0. Is this making sense now? Okay, so this is almost what I want. I want to show you not only that this happens, but in fact this happens. We have a strict inequality. Now, I'm going to wave my hands a bit here. I'm going to say, look, at time t, at expiration, portfolio A is worth this. Now, whenever St is greater than x, whenever we find ourselves here, the maximum of St and x is going to be strictly bigger than St. So sometimes, with some positive probability, portfolio A is going to be worth strictly more than portfolio B at expiration. So here's the point where I wave my hands a bit, and there's an exercise in your homework sheet that shows you how exactly I'm waving my hands. I'm going to say, because portfolio A is strictly more valuable than portfolio B with some positive probability at expiration, then we have the same relationship at time 0. People are willing to pay a bit more for something which has a positive probability of being strictly more valuable than the other thing. So not only do we have this weak inequality, we have the strict inequality. Okay, I'm not going to ask you if this is okay, because you're not going to answer me, but I'm going to give you the chance of understanding the next argument, which is similar. So now I want to convince you that that inequality holds. And I'm going to come up with two other portfolios. And these are going to be portfolio C and portfolio D. What do I see in portfolio C? I see a put option expiring at time t with strike price x and 1 unit of the underlying asset. So that's what portfolio C has in it. And then we're going to have portfolio D, which is going to have cash. How much cash? X times e to the minus RT, and that cash is deposited for t years at an interest rate of R. So let's ask ourselves, what happens at expiration, at time t? So let's start with portfolio D. It has cash. We put it in the savings account. After t years, we're going to collect back X pounds. That's the amount of cash in portfolio D. But now let's ask ourselves, what's happening with portfolio C at expiration? So let's remember now, what do put options do for us? So I'm plotting a pair function on the underlying asset price at expiration axis, payoff axis. And we said, if this is the strike price of your put option, the payoff is going to look like this. So now this is the happy zone, and this is the sad zone. So now let's see what happens to portfolio C depending on which sort of a future do we find ourselves in. So if we find ourselves in the happy future, if the underlying asset price is less than X, we're going to exercise the option. So we're going to take this share, this 1 unit of the underlying asset in portfolio C, we're going to sell it for X, and then the portfolio at expiration is just going to be worth X. And if after t years we find ourselves in the sad kind of future, we do nothing with the put option, the option is not exercised, and then the portfolio is worth, well, what's left in the portfolio? 1 unit of the underlying asset, which is worth ST, as I emphasized last time. So after t years, portfolio C is worth, well, when ST is bigger than X, it's worth ST. When ST is less than X, it's worth X. So we can summarize this by saying portfolio C is worth the maximum between ST and X. So now we look at this and we compare this to what happened to portfolio D. Portfolio D is always worth X at expiration. And so now the maximum between ST and X is always greater or equal to X. So we have portfolio C whose value at time t is greater or equal to the value of portfolio D at expiration time t, we have the same relationship at every previous time. In particular, we have the same relationship between the prices of the portfolios at time 0. So let's write down what is this telling us about time 0. We look at portfolio C at time 0. What do we have to do to buy one of these? We have to buy a European put for P pounds, and we have to buy a share for S pounds. S is the spot price of the underlying asset, and this must be greater or equal to the amount of money you spend buying portfolio D at time 0, which is the amount of cash in it. So we get this weak inequality, and again, we can say some of the time, with some positive probability, at expiration, portfolio C is going to be strictly more valuable than portfolio D. So at time 0, people are going to be willing to pay slightly more for portfolio C than portfolio D, because there is a slight chance that the price of C at expiration is going to be strictly bigger than the price of D. And in fact, not only do we get this inequality, we get a strict inequality. We get this inequality over here. Okay, so now with some trepidation, I'm going to ask you, is this making sense? Okay. And now I'm going to recycle two of these portfolios, and I'm going to show you some other interesting facts. So now I'm going to show you an equality. An equality satisfied which is satisfied by prices of European call and put options. And so again, we're going to have some underlying asset, which is going to be common to call and put options, which are identical except for the fact that one of them is a call option and the other one is a put option. So they have the same expiration time t and the same strike price. Then the claim is that the price of the call option plus strike price times e to the minus interest rate times time to expiration is equal to the price of the put option plus the spot price of the underlying asset. This is what it is saying. And this now should be very easy, because we're going to recycle portfolios A and C. So remember what was portfolio A. It's the same portfolio A as before. So we have a call option and an amount of cash equal to x times e to the minus rt, deposited for t years at an interest rate of r. And then we remember what portfolio C is. It had one put option plus one share. And then as part of the proof of the previous proposition, we show that at time t, both portfolios are worth the maximum between S, T, and X, the maximum between the underlying asset price at expiration and the strike price. Okay, so now we have portfolio A, we have portfolio C. We observe the prices of these two portfolios at time t, at expiration. We discover that at this time in the future, they will have exactly the same value. What can we say about the prices of these two portfolios at any prior time? They should have the same price at any prior time, including at the present, at time 0. So we ask ourselves, what is the present price of portfolio A, the spot price of portfolio A? We see one European call in it and this much cash. So this is how much you have to spend to buy portfolio A now. And if you want to buy portfolio C now, you have to buy a put option and you have to buy the underlying asset for S. So what's written here is the equality between the prices of portfolio A and C now. And we get this equality which I was trying to prove. Is this making sense? All right. So now, let's see, we have 5 minutes. So let's talk about American options. And let's specifically talk about American call options. So let's have a look at an underlying asset, some asset that does not provide income. So if you're talking about stock, if you're talking about shares in a company, let's assume that these shares pay no dividends between now and the expiration of these options we're going to consider. And now we're going to compare two kinds of options on this underlying asset. This underlying asset that pays no income. We're going to look at two options which are identical. In any sense, they're going to have the same expiration time. They're going to have the same strike price. They have the same underlying asset. But the difference is that one of them is American and the other one is European. So let me start from the end. I'm going to show you that in this situation, the price of the American call option, which is this capital C, is the same as the price of the corresponding European call option. And the way we're going to prove this is by convincing you that if you have this American call option, then, and if you're a rational person, which we're going to assume, then the optimal exercise of this American option. Remember, American options can be exercised at any time between now and expiration, but we're going to prove that the optimal exercise always occurs at expiration. It's never a good idea to exercise your option between expiration. Okay? If that's the case, then if you have an American call option, you're going to wait until expiration, in which case whatever payoff you get is going to be the same payoff you get from a European call option, and that is then going to force the prices of the American and European call options to be the same. So do you understand what I'm trying to do here? All right. So let's have a look at any time between now and expiration. So now is time 0, expiration is time capital T. Let's have a look at the time in between, a time which I'm going to call tau. And we can imagine what happens at time tau, and we're going to give a name to the underlying asset price at time tau. We're going to call it S tau. We're going to look at the price of the European call option at time tau, and we're going to call C tau. And we're going to look at the price of the American call option at time tau. We're going to call it capital C tau. And now we're going to also look at